Okay, now we're going to sketch these two trig functions here, 2 cos x and x sine x plus 30. Well, 2 cos x, if you know cos x, the graph of cosine, you know it goes through 0 and 1. And then in 90 degrees, it goes back to 0, and 180, it's down at minus 1. And in fact, it's got a period of 360 degrees, and minus 180 to 180, that's 360 degrees. And that's why this green graph is the right graph. The 2 makes it twice as tall. Instead of 0 and 1, you go up to 0 and 2. But it goes to 90 and 0, just like a regular, but it goes down to 180 and minus 2, down to minus 180 and minus 2, and minus 90 and 0, and that's exactly what it looks like. Looks the same as the sine wave, a cos wave, but that's the shape, and it goes right through 2 there. Now you just got to make sure that you label the y-intercept there of 2. Label the endpoints, 180 and minus 2, minus 180 and minus 2. Well, you're done there. Now let's look at this cos of x plus 30. Well, you should know that the sine graph goes through 0 degrees. 0 and 0, and then 90 and 1, and then 180 and 0. But this graph, something's happened. It says plus 30. That means that instead of going through 0 and 0, it will shift 30 degrees to the left. So instead of going through 90 and 1, it shifts and goes through 60 and 1. Instead of going through 180 and 0, it goes 30 degrees to the left and goes through 150. Instead of minus 90 and 0, which a normal sine graph would go through, you go instead of minus 90 and minus 1, a normal sine graph, you go 30 to the left and you get minus 120 and minus 1. And then you've got to check. Just put negative 180 and put 180 in here. 180 plus 30 is 210. The reference angle is 30. Oh, that just means, but in that quadrant, in the third quadrant, it's negative a half. It's the sine of 30 degrees is a half, but it's negative there. And this is negative a half. You've got to label those endpoints. And that's it. That's the whole thing. Now, this question, for which values of the graph between 0 and 180, so forget about this down here. I often don't read that carefully, but you got to read it. Between 0 and 180, where is f times g positive? Where is f times g a positive number? Well, I think we're talking about where is f times g going to be greater than 0? I think when they're on the same side of the line, like say here, 90 degrees, here, the red and the green line here, f and g are on the same side. I think that's why in between 90s, but not equal to 0, because it wouldn't be greater than, it would equal to 0. So in between 0 and 90, that looks like a place where it's going to work. And maybe they go back on the same side of the line. They're both negative here. They're both positive here. I think at 150. But not, less than or equal to 180. It'll work here, but not at 150. So you have to be careful of these inequalities. In between 180 and 150, but not 150 because it's 0 there, and that wouldn't make it greater than 0. So you look for the places where x is happening, where they're on the same side of the x-axis, and that's going to work. 2 positives multiplied, 2 negatives multiplied. And there you go. Another question done.